In the fields of economics and business, many applications require the use of lines and equations of lines. Hi, my name is Tom Atwater, and that's what we'll be exploring today: slopes of lines, parallel and perpendicular lines, and their applications. Let's start with the definition of increments. If a particle moves from the point x sub 1, comma y sub 1 to the point x sub 2, comma y sub 2, the increments in its coordinates are given by delta x equals x sub 2 minus x sub 1 and delta y equals y sub 2 minus y sub 1. Now, these little symbols that look like a triangle are read delta x and delta y. The letter is the Greek capital letter D, and it stands for the operation of difference or subtraction. Let's try these out. Find the coordinate increments from point A, which is negative 3, comma 1, to point B, which is negative 8, comma 1. All right, so we want to find delta x. And delta x is going to be equal to the subtraction of our x coordinates. So we have negative 8 minus negative 3. Of course, the double minus changes to plus, so it's negative 8 plus 3, and that's going to give us negative 5. Now, for delta y, we will subtract the y coordinates. So this would be 1 minus the 1 up here. And that would, of course, be equal to 0. And those would be our delta x's and delta y's. Now, we use these increments when we want to find the slope of a line. So let's look at how we would do that. The slope of a line, let the point P be x sub 1, y sub 1, and the point Q be x sub 2, y sub 2, and they are points on a non-vertical line L. Then the slope of the line L is equal to, we use m to represent the slope, and that's equal to what we call the rise over the run, which is equal to delta y, which is y sub 2 minus y sub 1, divided by delta x, which is x sub 2 minus x sub 1. Now, notice that the increments in the y direction is divided by the increments of the x direction, and that's where we get rise over run. Remember also that parallel lines that have the same, will have the same slope, and perpendicular lines have slopes that are negative reciprocals of each other. Let's look at an example. Let the line L be the line determined by the points A and B. First of all, plot A and B, find the slope of the line L, and then draw the graph of line L. We have two problems we'll do. Number one, we have the point A, which is 1, comma negative 2, and B, which is 2, comma 1. Our second example will be point A, 2, comma 3, and point B, negative 1, comma 3. So let's take the first one. We have, the first thing to do is to plot those points. So let me plot 1, comma negative 2, which would be right here, and 2, comma 1, which would be right there. The next thing we were asked to do is to find the slope. Now, the slope is equal to m equals the delta y, which is the change in the y, so we have to subtract the y's. So we'll have 1 minus a negative 2 over the change in the x's, which would be 2 minus 1. On the top, of course, the double negatives become positive, and so that would really be 1 plus 2, which is 3. And then on the bottom, it's 2 minus 1, which is 1. And of course, 3 divided by 1 is just 3. So our slope is 3. Now let's draw the graph, the line on the graph itself. So we draw a line that goes through those 2 points, and it would look like that. Okay, let's take a look at our second example, which had the point A as 2 comma 3 and the point B as negative 1 comma 3. So the first thing to do is to plot those. So 2, 3 is right here, and negative 1, 3 would be right there. Next, we want to find our slope, and our slope, which we use the m for, is equal to the top, which is the change in the x coordinates. I'm sorry, it's change in the y coordinates, so it's 3 minus 3. And then divided by the change in the x coordinates, so that would be negative 1 minus 2. On the top, we have 3 minus 3, which is 0. And on the bottom, we have negative 1 minus 2, which is negative 3, which, of course, we don't need to write because overall our slope is 0. So now let's draw the line that goes through these 2 points. And what we'll notice is that it is a horizontal line, which, of course, makes sense because we found our slope to be 0. All right, great. So now let's go on to vertical lines. And vertical lines are lines such that if you go through the point A comma B, it has the equation x equals a, since every x coordinate on the line has the same value a. Now for horizontal lines, if it goes through the point A comma B, it has the equation y equals b, since every y coordinate has the same value of b. Let's take a look at the point slope equation of a line. The equation y equals m times the quantity x minus x sub 1 plus y sub 1 is the point slope form of the equation of a line through the point x sub 1, y sub 1 with a slope of m. Now let's look at the general equation of the line. The equation ax plus by equals c is what we call the general form of the equation of a line. All right, let's look at an example. Write the general linear equation for the line that goes through the points 0, comma 0 and 2, comma 3. The first thing then is to use our formula, which tells us that y is equal to m times x minus x sub 1 plus y sub 1. So first, let's find the slope, which is m equals delta y over delta x. Well, if we take the point 2, comma 3 as our second point, we would go 3 minus 0 and just get 3 on the top. And by the same reasoning, 2 minus 0 to give us 2 on the bottom. So our slope is 3/2. So now we have y equals 3/2 x. And now we need to subtract off a point. Well, of course, the easiest thing to do would be to take the point 0, comma 0, because then it's just x minus 0, which is x, plus y sub 1, which is 0, so plus 0. So this is our equation, but this is in slope-intercept form, and that we were asked to find it in the general form. And what that means is I need to first multiply both sides by 2, and that gives me 2y equals 3x. And then what I need to do is get the x and y on the same side. And normally, because the x does come first as ax plus by equals c, we would want x to be positive and come first. So the way I'm going to write it is to bring the negative, or bring 2y over. So I'm going to get 3x minus 2y equals 0. And then that puts it into the general form of the equation of the line for us. All right, great. Now, let's move on to the slope-intercept form of the line. Now, the slope-intercept form, y equals mx plus b, is the slope-intercept form of the line where the slope is equal to m and the y-intercept is equal to b. Let's look at an example. Find the slope and the y-intercept for the graph, and then graph the line 3x plus 4y is equal to 12. So let's take that equation and put it in slope-intercept form. To do that, we want to isolate y. We have 4y equals negative 3x plus 12. Now we divide everything by 4, so we have y equals negative 3/4 x plus 3. That's now in slope-intercept form. Our slope, of course, is the negative 3/4, and our y-intercept is 3. So to graph this, we would go to the point 0, 3, and then use our slope, which says to go down 3 and over 4, which would bring us to this point, and then we draw our line through those 2 points. All right, that was great. Well, now it's time for you to try a problem. So the problem I'd like you to do is this. Find the slope and y-intercept of, and then graph the line, x over 3 plus y over 4 is equal to 1. Pause the video while you work on this problem. And when you are finished, restart the video to check your solution. Let's find out how you did on that problem. I'm going to recommend that we multiply both sides by 12, which is the least common denominator, clear out the fractions. So multiply by 12 and multiply by 12. So here we're going to get 4x plus 3y equals 12. Now I need to subtract 4x from both sides. So 3y equals negative 4x plus 12. And then finally divide both sides by 3. So y is equal to negative 4/3 x plus 4. Okay, so what that tells us is that our slope is negative 4/3 and our y-intercept is 4. So now we want to graph those, and we start with our y-intercept, which is 4. So we get our point right there. And now use the slope, which tells us to go down 4 and over 3. That would bring us to the point 3, 0. And then we draw our line through those 2 points. If that's what you got on your problem, then you have a great idea of how to put it into slope-intercept form and graph that line. Now, let's see how lines might show up in applications. So here's a word problem for us. The pressure P experienced by a diver underwater is related to the diver's depth D by an equation of the form P equals K times D plus 1, where K is a constant. And of course, at the depth of 0 meters, the pressure is 1 atmosphere. They give us the information that the pressure at 100 meters is equal to 10.94 atmospheres, and then we want to find the pressure at 50 meters. So what's important here is that we know the equation is pressure is equal to the constant times D plus 1, and we have the specific information that at a depth of 100, the pressure is 10.94. So let's substitute those numbers into the equation. So we get 10.94 equals K times 100 plus 1. So that gives us 9.94 equals 100K. And then K will equal 0.0994. That means our equation becomes P equals 0.0994 times D plus 1. All right, so now what they've asked us to do is to actually find what the pressure is at a depth of 50 meters. So to do that, we need to take our equation, which is pressure equals 0.0994 times 50 for the depth plus 1. So when we work out the math, we'll find that the pressure is equal to 5.97 atmospheres. So that was an example of where we did an application of linear equations to a word problem. In this lesson, we learned how to find the slope. We learned many forms of the equations of lines, as well as how to apply lines to word problems. Be sure to work the exercises that your teacher assigns, and we'll see you next time.